Hello, this is a relaxed look at Life After Delicious, a social networking site where I used to store all my links. This is a new one called Marklet.com. I recommend that you install it. I'm going over here. Up the top I've got 5 favourites, and then I've got it arranged in 3 columns here. That's web publishing you saw here. This is current work, so this is input work on the left column. Here, the Penrith High School Moodle, and online software for maths. Now what we have here is things that you need when you're publishing. So let's start off with information sources. Click that, and we'll look at here science simulations. You need these science simulations. I'm going to show an overall quantum mechanical feel for things. Here is a picture of an actual real live quantum mechanical atom, a hydrogen atom, absorbing its resonant frequency, and as the electromagnetic wave comes in, it gently caresses the atom into a new state. Going down here is a more quantum mechanical view, is the electron wave function. So electrons of old used to be these tiny little points, but now they are large wave functions. And you've got in the centre here the wave function growing. So go for that's 100%, 50%, and 2%. As it goes up and down, you can see it's radial wave function. Getting back onto this, we close that group of links, and we go down here. Whole series of sites you'd need for social references. Just on the quantum mechanical theme, we're going to the periodic table. Look here, the periodic table, particularly that helium was on the left-hand side, but if you swap to the quantum mechanical orbital view, it gets put rightly in the S block over here. You see those little brown and blue orbital features. The brown represents negative, blue positive phase of electrons. Electrons aren't points, but they're actually beautiful, squishy, soft, large things. And those little shells there represent radial nodes where it comes in. Now, the actual quantum mechanical view of the periodic table is more like this. You've got your S, F, D, and P shells filling inwards due to the Aufbau infilling principle. You've got alkaline earths which don't stretch all the way up. You've got helium again is on the left-hand side above beryllium, quantum mechanically. What's also of interest is the actual orbital types, which are those blue blocks in the centre. These represent, if you recall, the shells with the principal quantum number, which is the 1, 2, 3, 4, 5, and 6. And then the orbital quantum letters, which is S, F, and P. That's a very interesting shell there. Going back again, we'll close up the science references. And here's a series on the right hand side, the things that you, when you're bored, you can just look at. And these are a series of really good documentaries to look at. Here's prezzies that I have built for the various courses I've taught. If you go into there, you can actually see what's going on. And finally, recommend software that you download. And a new piece I'm going to add is Light Shot, which allows you to capture. Celestia is excellent. So these are things that you download onto your computer. And see, it's down here. And this is a picture of a quantum mechanical hybrid orbital. I sort of rather like playing around with it and seeing what shapes you can get. This is rather nice because they're actually like 2 little people hugging each other. And go around that gap there is just due to the fact that it's an old 2000 program, so the computer speed's not there. And we're going to take a cut of this, a quarter of it away, so we can actually see in detail what's going around. That's hidden from us in this view. Rotate. Okay, we can see inside here the actual shape of it going through. It's rather nice to look at. Just have a few seconds looking at it, rendering. You can speed up computers, but this is really not a 64-bit application, it's a bit old one. You can see my screen recording software. I've decided to leave it on the same screen because it's easier to see navigate what's going on rather than zooming in. Now this is how you actually save this for export to other people. So you can actually download this by pressing this export button over here. And here we can look at it in export format. So this is a file that you can save. And we close that. And if we wanted to import that, we'd go up here to import, and then we'd choose the file from our downloads. Don't upload it yet. And opening up here in our downloads, it's over here, you just press that. And away you go, but I'm not going to do it this time. And we'll close off this. And we're back to, so thanks for looking. This is the new social networking site with a bit more of a quantum mechanical feel.